Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Before we begin, a note from our sponsor. I'm Richard Jacobs, Executive Director of the nonprofit Finding Genius Foundation and host of the Finding Genius Podcast. In late 2016, I was rear-ended at 65 miles an hour by a truck on the highway, which sent me off-road into a ditch. The impact of the collision gave me a concussion and other injuries. At the hospital, a CT scan showed that I had thyroid nodules, which turned out to be cancer. It was then, when I had a biopsy of my neck, that I realized even if I was a millionaire, I wouldn't want a second or a third biopsy due to the pain and the invasiveness of it. And appointments at that time for thyroid experts were 3 to 6 months out. And I was worried about dying now, even if that was irrational. So because of this, I've decided to raise money to conduct a literature review on steroids, on the causes of anxiety and depression, a condition that affects well over 50 million people in the United States and hundreds of millions worldwide. Our goal is to create a codex, a guide that reveals all possible treatments for anxiety and depression for people that live with the condition, or for loved ones that have it, as my wife and my son do. To find out more about our fundraiser, visit findinggeniusfoundation.org and click on current initiatives. And now, to our guest.
Hello, this is Richard Jacobs with the Finding Genius podcast, now part of the Finding Genius Foundation. I have Ben Marzeion. He's a professor at the Institute of Geography and MARUM, part of the Center for Marine Environmental Sciences at University of Bremen in Germany. And we're going to talk about glaciers and how climate change may affect them. So, Ben, thanks for coming.
Hello, Richard. Thank you.
Yeah. Well, tell me about your background. What got you interested in studying glaciers and glaciation, years ago?
So my background actually in terms of education is not in glaciology, it's actually in oceanography. So I was studying the physics of the ocean circulation. For a couple of years, I was really interested in how the Atlantic circulation in particular responds to climate change. And I was using numerical models as my tools. So basically the idea with those numerical models is that you try to put the physical understanding that you have of the system into mathematical equations, and you put them into a computer, and the computer solves them and tells you how the system is going to respond. And so then really just by coincidence, I ended up having a job in Austria at the University of Innsbruck. And Austria is a landlocked country. It's in the Alps. So people were not that interested in oceanography, but they have quite a strong tradition in glaciology. And so basically over a couple of years, I started to mix my experience in numerical modeling with the experience in glaciology of the other scientists around me. And it turned out that, I happened to be at the right place in the right time, I would say. So basically, numerical modeling of glaciers was a gap at the time, particularly at the large scale. And so over the past roughly 10 years, I would say, this field really started growing. When I started doing that, it was really just a handful of other scientists around the world, maybe 5 people working in that area. And now, it's still a small field, maybe it's 20 or 30 people or so, but it's quickly growing and evolving.
Yeah, that's interesting. So you were interested in the oceans, and then your career slowly started to solidify and freeze over and turn into the study of glaciers, huh?
Yeah, in some respect, you can say I'm also slowly moving back towards the ocean because glaciers are really important for sea level rise. And so, also speaking scientifically, my background in oceanography really helps in that area because, I can look at the problem from both sides, from the side of the ocean, but also from the mountains, from the glaciers.
So I guess the 2 primary spots where glaciers come from is the Arctic and the Antarctic, or...
Yeah, many
glaciers appear in a lot of other areas as well. Like, where do they come from? essentially?
Yes. I mean, many people first obviously think of Antarctica and also the Arctic, but it's relatively important to really distinguish between the ice sheets, the big ice masses covering Greenland and Antarctica, and glaciers, which are more like the smaller bodies of ice that you find in the mountains. And so still also of these glaciers, most of them actually are in the Arctic, in the Canadian Arctic archipelago, in the European and Russian Arctic and so on. But there are also big masses of ice and lots of ice outside of the Arctic, in high mountain Asia, for example, Patagonia. And then you have many other regions where the ice masses are not so big, the European Alps, the Rocky Mountains, Scandinavia, and so on. But because there are so many different regions, these glaciers matter actually a lot. So there are roughly 200,000 glaciers in the world. And while each of them is relatively small, if they are working together, they can create quite an impact in the oceans as well.
So what are some of the glacier dynamics, as we go from summer to winter, winter to summer in the south and the north? Like how, Antarctica, how does it move and change throughout the year versus the Arctic?
Yeah. So, basically, all the glaciers work the same, you could say. So, every glacier is formed in a region where more snow is falling during winter than is melting in the summertime. And so when that starts, you can imagine having a mountain chain without any ice to begin with. And then if every winter a little bit more snow falls than is melting away during the summer, you start accumulating snow. And so just from the weight of the snow, you start to compress it. And so eventually it turns into ice. And while this ice on a human scale seems to be very solid, it's actually slowly flowing. So it's deforming. Part of it is also gliding on the surface of the mountains. And so this ice mass starts moving downhill. And so then what you get, when you get into sort of a steady state, then you have the situation that up on the glacier, every winter it's collecting snow. So more snow still is falling than is melting. But then the ice dynamics are moving this ice down valley. And so down in the valley is warmer. And so there the ice is melting. And so basically from this, you can say it's normal that glaciers are melting. Every summer, ice at the lower end of the glacier, at the glacier tongue, has to melt for the glacier to work in a sense. But what we are seeing now at the moment under global warming is that every summer more ice is melting down at the glacier tongues than snow is being accumulated up on the glaciers. And so this means then that the glaciers are getting smaller and that the meltwater is running into the ocean.
So when a glacier reaches a critical point, what happens? Does it just cease to exist the next winter? Like what happens as the glacier gets smaller?
Yeah, I mean, it doesn't go from one winter to the other. Typical response time scales of glaciers is of the order of decades to centuries. But basically what can happen is that you still have a glacier, you still have the ice in the mountains, but it's already doomed. So, and this is something that you can actually see in the Alps, for example. So if you travel to the Alps in the late summer, you will see that often there is actually no snow left on the glaciers, nowhere. Right. And so this means that this glacier no longer has an area where it's accumulating snow. And so basically it can keep staying there, for a couple of decades, but it's not being fed anymore by fresh snow. And so then it's just a matter of time until the glacier is completely gone. And this is also happening at the moment. So sometimes, in order to increase visibility of the problem, people report about this. There also have been sort of funerals for glaciers in Iceland and in Switzerland. But even if it doesn't draw special attention, some of the glaciers are well known, but many of them disappear without anyone really noticing. And so, yeah, this is happening.
And how do glaciers move? I guess in the summer, what the part of the glacier that's in contact with the ground, is there higher pressure, which liquefies the water, liquefies the ice, and that's what makes the glacier move? Does it glide along on a foot pad of water, or how does it move?
Yeah, I mean, it depends a little bit on how cold the ice is. So in many regions of the world, we say the ice is temperate. So this means it's really at the freezing point. So 0 degrees Celsius. Then you always have a little bit of liquid water around, and then the ice is really also sliding. But even for glaciers that have cold ice, so the temperature of the ice being below the freezing point, which may be actually then frozen to the ground so that you don't get sliding, you still get movement of ice. So the ice is deforming under its own weight. And basically you can imagine this like honey, flowing down the mountain, just a very viscous fluid, but it actually is moving. There are actually some really nice time-lapse photographies of this. So there's a documentary, it's called Chasing Ice, where they made time-lapse photography, and there you can really see how the ice is flowing like a liquid.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
So what are some of the interesting dynamics of glaciers besides them just melting and freezing and moving on occasion?
I mean, one thing that makes them, I think, particularly relevant, I mean, I already mentioned sea level rise. And of course, that's I would argue, one of the biggest impact we are going to see from climate change. But the other thing is that glaciers, when they are melting, the water flows past many people. So many of the streams that we have in mountains originate in glaciers. And so as the streams flow towards the ocean, they pass people, and people are using the water for agriculture, for industrial use in households. And so this is something we really need to be aware of, that as the glaciers are changing, there is the sentimental aspect to this, right? People enjoy mountain landscapes, and for many people, glaciers are just part of the mountain landscape. But also, people living in the mountains are really going to be affected by the glaciers melting, because it changes the seasonality of water availability. So basically, what glaciers are doing in that respect is that they are taking precipitation that is falling during wintertime, the snow that ends up in the glacier. They store it for a couple of decades or centuries, and then they release it during summertime. And so they shift the availability of water from wintertime precipitation into summer runoff. And this is something that is changing now as well. And in many regions, people will have to adapt to that.
Yeah. How many areas are there where, unless the glacier melts and provides water during the spring and summer, that the whole area will go into a drought?
I mean, there are not many areas where you would get a total drought. There are some areas that are particularly vulnerable. And Central Asia I would say it's the hotspot for this. But then there are also smaller ones. The western side of the Andes Mountains, for example, they get very little precipitation during some parts of the year. And in these parts, it's really the runoff from the glaciers that is providing the water. And there's also, there's this interesting aspect of an impact that is created not just from the natural system changing, but also from society changing. And I'm thinking of a particular example in Peru. And it's a region where population growth has been really strong. And also economical growth has been strong. And so what happens is that the people kept using more and more water. And it was possible because the glaciers are melting. So every time the glaciers are getting rid of some of the mass of ice they are storing. And so they were enabling people to have this growing demand of water. But of course, it's not sustainable. So as the glaciers are melting, they are getting smaller and smaller, and eventually they will stop functioning like that. And so this then creates this interesting aspect that you can say, okay, economic growth, changing lifestyles with more water usage and so on, worked for some time because of this unsustainable melt of the glaciers. And now we can see that the gap is opening. So the glaciers are now getting so small that they are no longer fulfilling that function. And at the same time, the water use is quite high. And that's creating quite some problems.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
Are there places where glaciation is increasing, ice is increasing, or is it just all across the world and over the whole Earth, it's just decreasing?
Yeah, you always find some small regions where for a couple of years glaciers are growing, but it never lasts particularly long. So there was one region or one phenomenon in the region of the Karakoram. So it's quite far west in the Himalaya mountain chain, where glaciers seem to be growing or at least be stable for a couple of decades now. But also there, we are now seeing that those glaciers starting to shrink. And basically, what happens there is that glaciers not only respond to temperature change, of course, they feel it if it's getting warmer or it's getting colder, but they also depend on precipitation. And so if you look at the globe, you're always going to find some regions where you get a couple of cold years or where you get a couple of particularly wet years. And so you will always see the situation that you find one region or another where glaciers are actually growing, but it never lasts particularly long. And also we really see that those cases are getting quite rare now. So if you go a couple of decades back, you would, basically in any region, you would find a glacier that is growing, and now you will have a really hard time to do that.
So what do you understand, because you have knowledge of both glaciers and you also have, an oceanography understanding? What do you know that other people that just study glaciers don't know?
I would say it's a little bit the impact also that the fresh water can have on the ocean. So, when the glacier melts and the water ends up in the ocean, obviously sea level goes up, but also the salinity of the ocean changes. And the salinity is important for the ocean circulation because the density of the ocean water depends on the salinity. And so because of that, there are some interesting feedbacks possible that a glacier melting changes the salinity of the ocean. This changes ocean currents. And some of the ocean currents are quite important for heat transport. And so suddenly you change the temperature distribution on the globe because glaciers are melting, right? And this is something where you can sort of see that you need both an understanding of how glaciers are working and how the ocean is working to be able to see potential mechanisms that might come into play.
Well, what do you mean freshwater has an interaction? So the precipitation on the land masses, I would guess, it doesn't rain in salt water, so it's all fresh. So I think most glaciers are fresh, but, once they reach a body of water, there's, if it's salty, there's mixing. So what's the dynamic of glaciers that stay on the land versus ones that, are touching the sea?
Yeah, so these glaciers, they are called tidewater glaciers. So basically you can imagine a glacier growing and keeping growing till they actually reach the ocean. And in the Arctic, many glaciers do that. And there you also get some interesting dynamics going because it's no longer just the atmosphere that is interacting with the glaciers, but it's also the ocean directly. So if the ocean is warming up, it starts to melt the glacier at its front. And so then often the front becomes unstable. And so you get carving of icebergs and icebergs are forming. And so basically now you have to consider two different things acting on the glacier. It's not just what the atmosphere is doing, how much snow you have and how much ice and snow are melting if it's getting warmer during summer, but also you have to think about what does the ocean actually do? How much ice can the ocean melt directly? And then how much ice is breaking off as icebergs, which are then floating out into the ocean and melting somewhere else.
Well, again, what happens at that dynamic? The salt water erode glaciers much faster because of the salt content, where the salt goes into the glacier tips and tongues and erodes it faster.
Yeah, so it's not so much the salinity that matters. Salt water has a lower freezing point than fresh water. Because of that, it actually does matter a bit. What is more decisive is really the heat that is being provided by the water. So if the ocean water is not right at the freezing point, then it will keep eating away on the glacier. And if you sort of try to imagine what a glacier front that reaches the ocean looks like, you often have this almost vertical cliff at the front. It's a carving front. And so the ocean will actually undercut the glacier there, right? So because the glacier front will melt faster within the water column than in the air. And so you get this undercutting effect, and from that you can get icebergs releasing. Then I mentioned they are called tidewater glaciers, and that points to the tides acting there as well. So the water level is rising and sinking twice daily. And so from this, it's sort of, it tends to uplift the ice a little bit and then move it down again. And so it's creating physical stresses. So it makes the ice move up and down. And so from this also you get fractures in the ice, which can create icebergs. So there are all different kinds of things going on.
So with the patterns of ice formation, do they make a pattern? If has anyone put all the glaciers around the world into a computer model and looked at the ebb and flow of them? And if so, do you notice anything interesting?
Yes, I mean, that's basically what we are doing. Main tool is numerical models. And so basically what we did in my working group is develop a model that is able to simulate any glacier that you might have in the world. But then, when you talk about patterns, they are not so much regional patterns, I would say. It's rather that under certain atmospheric conditions, you get certain types of glacier behavior. So you have some glaciers that are living in relatively cold and dry environments, particularly in the Arctic. So in the Arctic, it's cold. Everyone knows that. Necessarily, it also means that it's relatively dry because cold air cannot transport that much moisture. And so these are glaciers that are living sort of a slow life. And so they receive little precipitation every year, just a little bit of snow, but also during summertime, it stays cold, so not much ice melts. And so those glaciers are moving relatively slow. And then you have other areas where you have lots of precipitation. And so Alaska is a good example for that, but also Patagonia or New Zealand, Western Norway. Often it's the west coast of the continents where you get lots of precipitation. And in those cases, the glaciers receive a lot of ice, receive a lot of snow, and they turn this into a lot of ice. And so this ice then is flowing relatively fast down the mountains, and it can also go deep down into the valleys in Alaska and Patagonia, often reaching the ocean, so that you get those tight water glaciers. And those glaciers, you could say, they are living a fast life. So they have high turnover rates. They are faster to respond to changes in the climate forcing than those really big and relatively dry and cold glaciers high up in the Arctic.
So what happens to a glacier that, is, like you said, living a slower life? Does it compress over time? And does the nature of the ice change? Does the composition of the glacier look different for certain ones versus others? And, what are the factors that govern that?
It's not so much the material properties of the ice change. I mean, you find this cold ice really below the freezing point, only in really cold areas of the globe. And that does make the ice a little bit more stiff, so it will not deform as easily as temperate ice. But really what matters most there, I would say, when I'm saying glaciers living a slow life or a fast life, is how fast they also respond to climate change. So I mentioned that, you can go to the Alps now and see some glaciers that are already doomed. The ice is still there, but it's already clear now that they will not be able to survive, no matter how climate may change in the future. And if you have a glacier like that high up in the Arctic, it's going to stay there for a lot longer than if you have a glacier like that, let's say in Scandinavia, where everything is happening a little bit faster. And so basically, what you can say is that the disequilibrium that you get between the state of the glacier and the state of the atmosphere may get larger. Right? So you can imagine a world that has warmed by 3 degrees Celsius or so, if we look 70 years into the future or 80 years, and then some of the fast-living glaciers will be completely gone, but there are others going to be there, which also eventually will be gone, but they need a lot longer to melt and to respond to this climate change.
So what are the overall dynamics of the Arctic versus Antarctica? How would you compare them in terms of the melting and the freezing of ice and, the dynamics of how they change form every year?
Yeah. I mean, basically, the main difference is that in Antarctica, everything is really dominated by this big ice sheet. And when you look at a map of Antarctica, you can see that basically everything is covered by ice, and melting of ice at the surface plays a really small role. So basically in Antarctica, it's cold enough so that even during summertime, you get very little melt at the surface. Basically, you have all solid ice and snow in Antarctica. And so the only mechanism that Antarctica can get rid of ice that is collecting as snow is by producing of icebergs, right? So you get huge ice shelves around the continent. So this is the part of the glaciers that is actually floating in the ocean. And then at the front of those ice shelves, you get icebergs breaking off, drifting out into the ocean. And you do get things like this also in the Arctic. So also Greenland has outlet glaciers that form small shelves and so on. But in the northern hemisphere, in the Arctic, the melt at the surface is far more important. Because of that, there was also for quite some time a discussion going on whether Antarctica would actually really get smaller due to climate change. And by now, we are quite certain that it will get smaller, but it wasn't as easy to see because you could tell the story like this. So if it's getting warmer, the air can transport more moisture. So more snow will be falling in Antarctica, and likely this is going to happen. But then the question is, okay, if it's getting warmer, does it actually matter for the ice whether the atmosphere is at minus 10 degrees Celsius or at minus 5 degrees Celsius? Because as long as you haven't reached the freezing point, it doesn't mean that you're going to increase the melting. And now what we are seeing is that the ice dynamics are really changing. So more icebergs are being produced. The ice shelves, those floating portions of glaciers around the perimeter of Antarctica, they are getting thinner. The ice is getting more brittle. It's breaking more easily. And so then basically what happens is that the ice is starting to flow faster into the ocean. And because of that, we are quite sure now that also Antarctica is going to get smaller and is going to contribute to sea level rise. But the mechanism of this is quite different from what we are seeing in the Arctic.
So your modeling, what is it showing as some of the major watershed moments coming up? Is there going to be a dramatic change in the formation of glaciers or glaciation, soon or later, or what do you project out?
I guess one important thing that also tends to surprise people is how much ice in a sense already is lost. So how much ice is already committed to be lost, even if we imagine that climate change stopped right away today, right? No more climate change. We keep the atmosphere as it is now. Roughly 1/3 of the ice that we have in the glaciers now will be gone no matter what we do, right? And so basically what we are going to see there is that the glaciers keep responding to climate change that already happened in the past. And any climate mitigation, reductions in emissions of greenhouse gases that we are striving for now, we will only see the impact of that quite a bit into the future. That makes it sometimes a little bit hard to communicate the problem, because the danger is that people can say, well, if it's already too late, why should we then try to cut our greenhouse gas emissions? And the thing is, it's this incredibly long-term perspective that you need to take for understanding how the glaciers, and for the ice sheets it's even worse, you could say, how they are going to respond to changes in our greenhouse gas emissions. So what is going to happen depends to a large degree on what we decide today we are going to do with greenhouse gas emissions. But we are only going to see that impact towards the end of the 21st century, right? So you need to be really patient to see this paying off. And that's what makes it sometimes a little bit hard also for policymakers to see the urgency in doing this. That said, of course, there are also many other good reasons apart from saving glaciers why we should try to reduce greenhouse gas emissions, right? But just having the focus on glaciers, you have to be really patient to see it paying off.
I don't know. What are some of the big levers that will affect what's going to happen going forward with glaciers? Or is it, all you can do is just look and see the path we're on? If
we want to prevent some bad things from happening, the strongest lever we really have is cutting greenhouse gas emissions. It's very simple as that. In terms of, you said
it'll be a delay of decades.
Yes.
So again, what is going to happen regardless?
Well, glaciers will keep melting. So there's really nothing we can do about it. This is the Mars loss that I said is already committed. So it's not realized yet. You still see the ice in the mountains, but even if climate change stopped today, the ice is going to melt. So it's, basically you can say it's only there because it takes time to melt. But it's already, the technical term actually is dead ice. So it's a body of ice that is disconnected from an area where snow is accumulating every year. Right. And so you still have the ice there, but it's no longer a living glacier. And so there is very little we can do about that. On the very, very small scale, in the Alps, some skiing areas are doing that. They are covering the glacier because they have infrastructure built on top of the glacier. And so, for them, it's very costly. The ice melts. They actually have to rebuild their infrastructure. And on the very small scale, that works. So insulating the ice does work, but you can only do it on very small scales, and it's also really expensive. Otherwise, there's very little we can do about glaciers melting for the next couple of decades. What we really can do is preventing glaciers from keeping melting at so high rates at the end of the 21st century.
Is there anything happening with the worldwide glacier movement that doesn't make sense to you or doesn't make sense to your model? Any strange effects?
When you try to model glaciers on the global scale, you're always going to have some problems with some glaciers. You never get perfect results for all the glaciers. That's basically impossible, but not in the sense that we would be worried that we are missing something fundamental. So the problem we have is that it's really hard to get data from the base of the glaciers. We have satellites and they are providing great amounts of data and increasingly good qualities of data. This is all very fine, but you cannot see through the ice. And so one of the big problems actually is that we don't know how thick the ice is. We don't know it from measurements, let's say that. So there are ways to estimate how thick the ice is of different glaciers, but we don't really know for sure. And so basically, there are always data missing, and because data are missing, we can't reproduce every individual glacier's behavior exactly in our models. But looking at the large picture, basically, I would say the physics of this are understood. I would be really surprised if in a couple of years we realize that we missed something fundamental in our understanding of how glaciers work.
Very good. Well, Ben, what's the best way for people to find out more about your work and see your modeling results? Where can they go?
The model that we are using, it's called the Open Global Glacier Model. And we actually have an educational website for that. So Open Global Glacier Model, it's called OGGM. And so people can go to oggm.org or to edu.oggm.org. And there you can actually find some very simple ways of looking at glaciers and also at the glacier model and try around. You can actually run the glacier model in your web browser. You can change temperatures, you can change snowfall and so on and see what happens to the glaciers. That can be quite fun.
Oh, that's very cool. Well, very good, Ben. Thank you for coming on the podcast. It's been a very interesting call.
Thank you.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.